All right, we are on into our next unit on solutions, and we will periodically be revisiting gases as well. And so make sure that you are asking questions, and we will go over our gases quiz as well. I know some people still haven't taken it, so can't discuss it yet, unfortunately. So solutions, here's some standards, and we will just kind of intro it today, so not a heavy day. Properties of solutions. Characteristics of a solution. It's a type of mixture that contains a uniform composition throughout. Remember that a solution is another word for a homogeneous mixture. That's back from Unit 1. And so that is going to be in a single phase. These are physically combined, and so they can be physically separated. A couple ways that you might hear us discuss separating the components of a solution are by filtration or distillation. Filtration is when you're separating them by particle size. Distillation is when you're separating them by boiling point. So the examples of solutions, if you remember these from, again, Unit 1, would be salt water, Kool-Aid, lemonade, or steel. So steel would be an example of a solid solution. So some new terms here. Parts of a solution. You can get kind of tongue-tied with these, so pay very close attention when you are hearing me speak about these parts. The first one is the solute. This is a new term. The solute is the substance being dissolved. It is going to be present in the lesser or smaller amount compared to the other substance. Then you have what's called the solvent. You've probably heard of a solvent before. And it's the substance that is doing the dissolving. And it's going to be the substance present in the larger amount. And at this point, we want to make sure that we talk about water. Water is considered the universal solvent. Why? Because so many things dissolve in it. You have ionic compounds, because they have full positives and full negatives. And then you have polar covalent substances that dissolve in it, because water is polar covalent. And so those are partial positive and partial negative things. So that's a lot of different substances. The only things that wouldn't dissolve in it are things that don't have any positives or negatives, or partial positives or partial negatives. So then I just copied a list of examples of solutions. A lot of kids think that solutions can only be like solids dissolved in liquids, but as you can see, there's a lot of different things that have been composed of different solutes and different solvents. Then we have types of solutions. You can have an electrolyte, letter C, or a non-electrolyte. So an electrolyte is a type of solution that contains ions, and those ions, because they are free to flow and carry a charge, will conduct electricity. So anything that's an ionic compound that dissolves in water is going to be considered an electrolyte. So for example, sodium chloride. Acids and bases, especially if they're strong acids and bases, because they dissolve in water, will be considered electrolytes. Non-electrolytes are things that do not have ions. So when they even if they dissolve in water, like sugar, sugar doesn't break up into ions, so it won't have positive and negative particles to carry a current or to carry a charge. So they're considered non-electrolytes. So even, again, even if it dissolves in water, it can still be a non-electrolyte. All right, next, the solution process. This is also called solvation. Not to be confused with what happens in a church. Solvation. Letter A, what happens first is when the solute particles break apart. And this is when you break apart the forces of attraction that keep those solute particles together. So down below in the picture, that would be those particles of attraction that hold together the sodium ions and the chloride ions, breaking those forces of attraction. This is going to require energy. The second step is when the solvent particles break apart. So this is when the water molecules break apart from each other. And this also is going to require energy, because you have to overcome those intermolecular forces. But you're going to form new forces, and this step releases a lot of energy. Those new forces occur all the way around here, all the way around here, all the way around here, etc. And that's a lot of energy. And so that's the process of what's called solvation, or the solution process. Next we have this is a day full of, again, a bunch of vocabulary. So the next definition that we're going to cover is what's called solubility. And a lot of kids get solubility actually wrong, especially on tests, because they miss one important concept. They just think it's the amount of solute that will dissolve. And it's very important that you understand that solubility is the maximum amount of solute. The amount of solute is the concentration. The maximum amount is the solubility. So it's kind of like the difference between speed of your car and speed limit. When you're driving down the road, the speed, you look down at your speedometer, that's the speed you're going. That's like concentration, the concentration of a solution. But then when you look up and you see a posted speed limit sign, that doesn't change. That's what's called like solubility. So the maximum amount that you can get to dissolve doesn't change. So if I have a cup of coffee, I can only get so much sugar to dissolve in it. I may choose to put 1 packet of sugar in it. I may choose to put 2 packets in it. But if the maximum number of packets I can get to dissolve in it is 8, and no matter what I do, I'll never get 9 packets in, then 8 is the maximum I can have in it. I can have 1, that can be my concentration. I can have 2, I can have 2.5, I can have 3. That's my concentration. But the maximum I can always have, its solubility would be 8. So solubility is the maximum amount that I can have, but it's also dictated by the temperature, because if I heat up my coffee, I'll probably get some more to dissolve. So make sure you know that. All right, then we have soluble and insoluble. That's kind of easy. If it's soluble, it will dissolve. If it's insoluble, it won't. Miscible and immiscible means the same thing, except it's specific to liquids. So like if you have vinegar and water, they will dissolve in each other, but oil and water will not. Now, if we have saturated solutions, that's when a solution is at the point of solubility, that means it's saturated. If it's below the point, it's unsaturated. So back to my situation, if my cup of coffee, here's my mug, so pretty here. If I know I can put 8 packets in it, and I have 8 packets in it, I'm at the point of solubility. But if I only have 3 packets, I'm below the point of solubility. Supersaturated is when I'm above the point. So maybe I put 9 packets in. I can only get 8 to dissolve, but I go ahead and heat my coffee up, get that extra packet to dissolve, and then I cool it back down. That extra packet is going to stay dissolved. That's called supersaturated. All right, last but not least, let's see if I can get this in before I lose my time of less than 15 minutes. One last thing on solubility. Factors affecting it. Bonding, polarity, and IMFs affect the degree of forces of attraction between solute and solvent. You need to understand a big rule here. Like dissolves like. What that means is similar solutions will dissolve in similar solutions. That means that ionic solutions will dissolve in ionic solutions. Polar dissolves polar, nonpolar dissolves nonpolar. So polar dissolves polar, nonpolar dissolves nonpolar. So KCl will dissolve in water. Why water? Because water is polar. Oil is nonpolar. How did I know that? Because I'm telling you that now. I know that. Why? Because water has hydrogen bonding in it. Water is polar covalent. Oil has a bunch of carbons bonded to each other in a row. So, and KCl is ionic. Now, Sharpie markers. You know that they do not dissolve in water. So if you know they will not dissolve in water, then by process of elimination, you know that they'll probably dissolve in oil. Pressure. Because gases are the only phase that have an appreciable amount of space between them, if you put them under pressure, what will happen? You can force them closer together. And if you force them closer together, you'll increase their concentration. So if you put them under pressure, such as in soda pop, you'll increase their concentration in the solution. Temperature. Increasing the temperature will cause the particles to speed up, and if they speed up, you'll get more to dissolve, and they'll be more soluble. However, if it's a gas and a solution, if you speed them up, what happens? If you speed them up, they hit the surface and they escape. Think about it. Where do you put your pop? Do you put it in the oven or do you put it in the fridge? You put it in the fridge.